proportions two samples. In all two sample test situation, we have two groups. Those groups can be considered to be subparts of a population, like male and female, or they could be considered to be just two separate groups, national and foreign. For each of those two groups, we'll have true proportions. So for group 1 we'll call that P1, and for group 2 we'll call that P2. We don't care about the actual size of those proportions. What we do care about is the difference between the two. Is the difference 0? No difference. Is the difference not 0? In other words, is there no difference? Or is one bigger than the other one? To be able to answer those questions, we need samples for each group. So for the first group, we need sample size N1 and a sample proportion P hat1, which we need to understand is calculated by going x1, the number of items with a particular quality, divided by n1, the number of items in that sample. And similarly for group 2, sample size N2 and P hat 2, which is x2, number of items with a particular quality in group 2, divided by total number in group 2, N2. Remember that x's and n's are whole numbers or integers. The formulas that we'll use here, let's first look at z-calc. Remember that all the z-tests that we will do will be large sample tests, because the small sample tests are so difficult. So z-calc will be the sample difference, so P hat 1 minus P hat 2 minus the hypothesized difference, P1 minus P2, and that hypothesized difference will always be 0 in a one or two-tailed tests, and we're going to divide that by the standard deviation, which is sigma hat, so P hat 1 minus P hat 2. Okay, so the z-calc is standard. We have a sample value, in this case a sample difference, minus a hypothesized value, hypothesized difference, divided by the standard deviation of the sample value. Alright, the standard deviation, sigma hat, so P hat 1 minus P hat 2 is equal to the square root of an item called P hat, which we've yet to define, times its complement, 1 minus P hat, times 1 over n1 plus 1 over n2. And remember, it's the square root of the whole thing, where P hat is the combined sample proportion. Right. What we have so far are two different sample proportions. What we need in this calculation is just one number. So what we do is we combine the two of them to get one value. Throw both samples together and get one. The formula for P hat will be x1 plus x2, right? The number of items in each sample with a particular quality, divided by n1 plus n2, total number of items in both samples. So that's a combined sample proportion, and the result must be between the two individual sample proportions. In a sense, P hat is a weighted average of P hat 1 and P hat 2, so your answer must be between them, otherwise you've made a mistake. Other than that, most everything is the same. We could have two-tail tests, and the null hypothesis for a two-tail test would be P1 is equal to P2, and the corresponding alternate, of course, would be P1 is not equal to P2. And there's your two-tail. For a one-tail, alright, for example, a lower tail test, P1 would be greater than or equal to P2, and the alternate, of course, the complement, P1 less than P2. In this type of problem, when we have a one-tail test, can we have to go through the routine of figuring out which tail? What we do is we compare the two sample values, but in the proper order. P hat 1 is compared to P hat 2. Alright, so either P hat 1 is greater than P hat 2 or P hat 2 is less than. If it's greater, we have an upper tail. And of course the alternate would have the greater than sign in it. If it's a less than, it's a lower tail. And the alternate in that case would be P1 less than P2. So a similar sort of process as before. Alright, that's basically the information that we'll need to do these two-tail tests on proportions. We'll stop here for the introduction.